So that mean speed is 16 times the range of speed. That is n mean is equal to 16 into n2 minus n1. The lengths of the ball and the roller arms of the bell crank lever are 100 mm and 80 mm respectively. So one thing, please understand, the lengths of the ball and the roller arms. The ball arm is A, that is nothing but 100 mm. The ball arm is given, the length of the ball arm is given, that is 100 mm, and the roller arm is given, that is nothing but B, that is nothing but 80 mm, which is given in the problem statement. The pivot center and the axis of the governor are 100 mm apart. The pivot center and the axis of the governor are 115 mm apart. So I will call it as R, that is the radius, 115 mm apart. So while drawing the figure, I will show you once again what is R1, what is R, what is A and what is B. For time being, you can take it as R is equal to 115 mm. Determine the initial compression of the spring. Initial compression is asked. Determine the initial compression of the spring, taking into account obliquity of the arms. So this is very, very important. In the previous problem, they have mentioned that neglecting the obliquity of the arms, you need to find out the initial compression. But in today's problem, it is given that we need to consider the obliquity of the arms. So neglecting the obliquity of the arms means what we used to do, we used to take C1 is equal to C2 is equal to 0 and A is equal to whatever the value given and B is equal to the value given. So here, along with the given values of A and B, we need to calculate C1 and C2 also. So it means the governor is in working condition. So it means we need to consider the figure which we have used while deriving the equation for the Hartnell governor. The same equation or the same figure has to be considered, and we need to calculate what is the value of C1 and C2. In mean condition or in mean position, how the governor will be? The governor will be like this. This is in the mean position. So this is A, and the radius is given. The centrifugal force will be acting radially outwards. So I will call it as F, and the value of B is given, that is the horizontal arm or the roller arm, and the value of A is given, that is 100. That is nothing but the ball arm. A is equal to 100. This length of A is 100, then this length of B is 80 mm. So with this, the value mg by 2 will be acting in the downward direction. So divided by 2, because we have considered only one half of the governor, and for this case the radius is given. If I consider this as the axis of the governor, axis will be at the spindle, and this is considered as R, and this value of R is equal to 115. So this is in the mean position. But in the problem statement, they have mentioned that we need to consider the obliquity of the arms. So it means in the actual position we need to draw it now. So I will draw it. Please go through it. If there are any doubts, please clarify. This is the axis. I will call this point as A, this point as B, and I will call this point as A and this point as B. So this length is nothing but it is 20. So why I have taken 20 here and 20 here? Because the total lift is given. The total lift is 40 mm. So in the minimum position I have considered it as 20, and in the maximum position I have considered it as 20. So the governor will be in mean position like this. For minimum position and for maximum position, whatever the lift it is going to take place, that total lift is 40. So out of that total lift, 20 for the minimum position and 20 for the maximum position I have taken. So this I will call it as B1. This distance I will call this as B1 and this as B2. This is B is equal to 80 and this is nothing but A is equal to 100. So this is the given figure, so which we need to construct depending upon the problem statement given. So if this is constructed, then nothing is there in solving of the problem. Only thing is that we need to find out the missing terms from the figure. So let us go for the solution. So these are the given data. So these are the given data from the problem statement. So once again I will read the question, just go through it, what we need to find out. In a spring loaded Hartnell type of governor, the mass of each ball is 4 kg and the lift of the sleeve is 40 mm. The governor begins to float at 200 rpm when the radius of the ball path is 90 mm. The mean working speed of the governor is 16 times the range of the speed when the friction is neglected. The lengths of the ball and roller arms of the bell crank lever are 100 mm and 80 mm respectively. The pivot center and the axis of the governor are 115 mm apart. Determine the initial compression of the spring taking into account the obliquity of the arms. So initial compression we need to find out. So first understand or first calculate the value of N1 is given, N mean is given, N2 is missing. So N1 is given, N2 is missing and N mean is given. So let us find out what is the value of the N2. So mean speed, we know that mean speed that is nothing but N is equal to N1 plus N2 divided by 2. So how we are going to write the mean speed? The mean speed we are going to write it as N is equal to N1 plus N2 divided by 2, as the mean speed is given as the 16 times the range of the speed. In the problem statement it is given that the mean speed is 16 times the range of speed. So whatever the value of mean speed is there, so there you can substitute this value of mean speed, that is nothing but N is equal to 16 into bracket N2 minus N1. So therefore N1 plus N2 divided by 2 is equal to 16 into bracket N2 minus N1. So that is nothing but the mean speed. So where N1 value is given, that is 200 plus N2 divided by 2 is equal to 16 into bracket N2 minus N1. So what I have done is I have substituted the value of N1 here, because the value of N1 is given as 200 rpm. So here N1 also I can substitute as 200. So from this you can find out what is the value of N2, and the value of N2 is 212.9 rpm. So this is the value of N2. So you have calculated the value of N2, so you have calculated the value of N1. So now I need to find out what is the value for C1, what is the value for C2, because the values for C1 and C2 is not given in the problem statement. The value of R1 is given, the value of R is given, and the value of R2 is also not given. So it means we can find out what is the value of C1, C2 and value of R2. So therefore, the angle turned by bell crank lever between two extreme positions. The angle turned by bell crank lever between two extreme positions is given by H by B. So the angle turned by the bell crank lever, the total angle turned by bell crank lever between two extreme positions is given by H divided by B is equal to C1 plus C2 divided by A. The total angle turned by a bell crank lever is given by H by B. H means the total height divided by B is equal to C1 plus C2 divided by this length, that is nothing but A. So if I consider this as angle alpha, then they have taken just the tan of angle. So if I consider this as angle, then it is opposite. This is opposite. So here this is C1 plus C2 is the total opposite and its corresponding adjacent length. So this is your adjacent, this is your opposite, this is your adjacent. So opposite divided by adjacent. So here also opposite divided by adjacent. So H by B is equal to C1 plus C2 divided by A. So therefore C1 plus C2 is equal to H into A by B. So C1 plus C2 is equal to H into bracket A by B. So you have the value for H, that is the total height is 40, multiplied with A by B. The value of A is 100 divided by the value of B is given. The value of H, the value of A and the value of B is given. So everything is given. So C1 plus C2. So therefore C1 plus C2 is equal to, so 41 za, 42 za, so 2 1 za, 2 50 za. So C1 plus C2 is equal to 50 and I will call this as equation number 1. So we have got C1 plus C2 is equal to 50. So now how to get the value of C1? So C1 I need to get the value. The total radius is known, that is 115. So in that R1 is 90 up to this point. So from this point to this point is the C1. So how to get the value of C1 from there? So C1 is equal to R minus R1. So this is total R, this is R1. I need this value. So this minus this is going to give us what is this value. So the value of R is given 115 minus R1 is 90, which is given in the figure. So C1 is equal to 25. So we know that C1 plus C2 is equal to 50 and I know the value of C1. So substitute C1 plus C2 is equal to 50. I know the value of C1 as 25 plus C2 is equal to 50. So C2 value is also 25 mm. So the value of C1 is also 25 mm and the value of C2 is also 25 mm. So I have calculated the value of C1 and C2. The next thing is I need to calculate what is the value for the R. The next step is to calculate the value for the R2. The R2 value has to be calculated because R is already given as 115 and R1 is given. So what is R2? R2 is nothing but it is a combination of R plus C2. So this is our total R2. So in that R is known, that is 115 and C2 also we have calculated. So R2 is equal to C2 plus R. So from this figure to get the value of C2 is nothing but it is the addition of R2 it is a R2 value we need to get. So R2 is what? It is the addition of C2 and R. So C2 is already known to you that it is 25 mm plus R is also known to us, that is given in the problem statement as 115 mm. So the value for R2 is 115 plus 25. So it is nothing but 140 mm. So all the values are known to us now. So all the values have been calculated. Next, we need to calculate the value of B1, B2 and A1 and A2, because in our governing equation all the values are required. So B1 is equal to B2, B1 is equal to B2 is equal to, so under root of, so how to get the B1 and B2 value? So this is B1 and this is B2. So out of which two values are known. One is 80 and another one is 20. So here also one is 80 and another one is 20. So under root of 80 square minus 20 square is going to give us the value of B1 and B2. So the value of B1 and B2 is 77.46 mm. So simple one, using the Pythagoras theorem you can find out. So this is your B1, this is your B2. So you can calculate this minus this is going to give us this, this minus this is going to give us this. So similarly you need to find out the values for A1 and A2 also. So I will call this as A1, I will call this as A1, and similarly this as A2, this as A2. So A1 and A2 we need to calculate. So A1 and A2 is equal to, A1 is equal to, A2 is equal to. So this length is known, that is 100, and this length is known, that is 25. So this total length is given to you, that is 100. That length is 100. And this length is known to you, C1 and C2 is known to you, that is 25. So you can get the value of A1 and A2 as 100 square minus 25 square, and the value of A1 and A2 is equal to 96.82 mm. So A1 and A2 value we have calculated. The next thing what we require is the values of omega 1 and the values of omega 2. So how to get the value of omega 1 and omega 2? So omega 1 is equal to 2 pi n1 divided by 60. So 2 into pi into n1 value is already given in the problem statement. So it is 200 divided by 60. So you can get the value of omega 1 as 20.94 radian per second. Similarly, calculate the value of omega 2. So to get the value of omega 2 we require the value of n2. So that also we have calculated, 2 pi n2 divided by 60. So it is 2 into pi into n2 is already calculated, that is 212.9. So divided by 60, and you are going to get the value of omega 2 as 22.29. 22.29 radian per second. So whatever it is required for our equation part, all the values have been calculated. So the next step is only substitution of all these values into the governing equation. So let us substitute all the values into the governing equation and find out what is the value for initial compression. Now let us go for the calculation part. In extreme position, So what is the governing equation for the extreme position? So it is given by F1 into A1 is equal to 1 by 2 into bracket mg plus Fs1 plus F multiplied with B plus mg into C1. So that is our governing equation for the extreme condition. As in this particular problem, so observe whether we have all the values or not. F1 value already we have calculated, that is or we can calculate by using the equation m r omega square. A1 value already we have calculated. M, that is nothing but the mass of the sleeve. So in this case the value of mass of the sleeve is not given, so I will take it as 0. If not given, then I will take it as 0, then this term becomes 0. Fs1 we need to calculate. What about the force of friction? The force of friction is also not mentioned in the problem statement, so take it as 0. The remaining term is only Fs1 divided by 2 into, this is for first case, so I will write it as B1 plus M is given, G is known, C1 is known. So whatever the unknown terms are there, you first remove them and write only the known terms. So the remaining known terms are F1 into A1 is equal to half into Fs1 into B plus M into G into C1. So this is the remaining term which is we are going to get after substituting the values of mass of the sleeve and force of friction. So F value we have not calculated, so we can calculate it by using the equation m1 r1 omega 1 square into A1 is equal to half into Fs1 into B or B1 plus mg into C1. So this is our equation. So in this equation substitute all the values. The mass of the ball is given, that is nothing but the 4 kg into the radius r1, it is 90 mm, so it is 0.09 meters. The value of omega 1 already we have calculated, that is 20.94 square, because it is omega 1 square, into the value of A1 we have calculated. The value of A1 is 96.82 meters mm, so it should be substituted in terms of meters. So it is 0.09, what is the value? 96.82. So it means 0.09682 is equal to 1 by 2 into Fs1, I don't know which I need to calculate, into the value of B. So B1 is equal to, B2 is equal to 77.46 mm. So it should be in terms of meters, 0.07746 meters plus mass of the ball is 4 into acceleration due to gravity 9.81 into the value of C1. So the value of C1 is 25 mm, so it is 0.025 meters. So all the values have been substituted. So the remaining unknown value in this equation is Fs1. So the value of Fs1 is given by 392.5 Newton. 392.5 Newton. So we have calculated what is the value of Fs1. So similarly, we need to calculate what is the value of Fs2. So Fs2, to get the value of Fs2, so use the other equation, that is F2 into A2 is equal to 1 by 2 into bracket capital Mg plus Fs1 plus F into B2 plus Mg into C2. This is the equation. So F2 is nothing but M2 R2 omega 2 square into A2 is equal to 1 by 2. So M is not given 0. So F is also not giving 0. So remaining term will be Fs1 into B2 plus Mg into C2. So substitute all the values here. So the value of M2 is 4. The value of R2 is 140. So 0.14 meters. So omega 2 value is 22.20. whole square into the value of A2 is 0.09682 meters, which is equal to 1 by 2 into the value of FS2. So this is FS2. FS2 we don't know, we need to find out the value of B2 is 0.07746 plus M is 4 into G is 9.81 into C2. The value of C2 is 25 mm, so it is 0.025 meters. So all the values have been substituted. So calculate the value of FS2 and it is 698 Newton. So we have calculated the value of FS2 and FS1. The next thing is we can find out what is the spring stiffness. So we know that from the derivation that Fs2 minus Fs1 can be written as S into H. We have seen in the derivation. So we have calculated the values of Fs2 and Fs1. So substitute the values of Fs2 and Fs1. That is 698 minus 392.5 Newton is equal to the S value we don't know, and the height or the lift is given, that is 40. So we can get the value of S as 7.64 Newton per mm. So the value of S is calculated. The next thing is to calculate the initial compression. So initial compression is given by the equation Fs1 divided by S. So we have calculated the value of Fs1. The value of Fs1 is nothing but it is 392.5 divided by the value of S is 7.64. So the value of initial compression is 51.37 mm. So this will be the end of the problem. So very lengthy problem, but the problem is very easy. The number of unknowns are more in this particular problem compared to previous two problems. So it takes time to calculate first all the unknown values, then nothing is there, only substitution part is there. So once you find out all the unknowns, you can just go on substitute all the unknowns into the governing equation for the Hartnell governor, and you can find out the value of initial compression. So initial compression is nothing but Fs2 divided by S. To get the value of S, we require Fs2 and Fs1 because the equation is Fs2 minus Fs1 is equal to S into H. So where we can calculate the value of S. So substitute the value of Fs1 and S, you are going to get what is the value for the initial compression. So this completes the third problem on the Hartnell governor, and also it completes the chapter of governors. So in the chapter of governors, what we have done, we have seen the different varieties of governors, then some of the basic definitions which are associated with the governors, then we have done the derivation of the Porter governor, then we have solved some problems on Porter governor, 2 to 3 problems, then we have done the derivation of the Hartnell governor, then we have done problems on the Hartnell governor. So we have solved totally 3 problems on Hartnell governor, and this completes the chapter on governors. So let us begin with the new chapter, that is Introduction to Vibration. The next chapter is Introduction to Vibration. So this is the next chapter. So whenever we come across a term called vibration, or in our day-to-day life, many of the times we are going to come across this term. In our day-to-day life, many of the times we are going to come across this term called vibration. So let us understand, what do you mean by vibration? So basically, vibration is a mechanical phenomenon where the oscillations are going to occur about an equilibrium point. So once again I will repeat, what do you mean by vibration? Vibration is a mechanical phenomenon whereby oscillations occur about an equilibrium point. So these oscillations may be periodic oscillations such as motion of a pendulum. So simple pendulum which we have seen in case of the theory of machines lab. So that oscillation may be a periodic or it may be a random also, such as movement of a tire on the road. The movement of a tire on a road gives an example for a random oscillation. Now the question arises, what are the reasons for the vibrations? The main reason for the vibrations can be such as, first one, because of the unbalanced centrifugal force in the system. So this is caused because of non-uniform material distribution in a rotating machine element. Second one is elastic nature of the system, and because of external force or excitation applied on the system, there may be a vibration, and because of winds which may cause vibrations of certain systems such as electricity lines, telephone lines, etc. Now, how to reduce the vibration? The question arises. The different types or different varieties of vibration. So vibration is a very wide phenomenon where we are going to classify the vibration as first one as free and forced vibration. First one is free and forced vibration. The second one is linear and non-linear vibration. Linear and non-linear vibration. So there are still many categories are there. So one by one we are going to discuss. So first thing, what is meant by free vibration and what is meant by forced vibration? After disturbing the system, if the external excitation is removed, then the system vibrates on its own. Say for example, there is a simple pendulum. So initially if I give the excitation or if I push the pendulum or the simple pendulum, then it starts to rotate. Even though only once I have pushed it or only once I have given the excitation for the simple pendulum, even though after removing the external excitation, the system vibrates on its own. So such vibration is known as free vibration, and the example for the free vibration is simple pendulum. The example for free vibration is simple pendulum. So this is the example for free vibration. Now, what is forced vibration? The vibration which is under the influence of external force is known as forced vibration. Please understand clearly the difference between free and forced vibration. In free vibration, what happens? Initially, I am going to give an excitation. So once I give the excitation, that excitation force or the external force is removed. But even after removing the external force or excitation, the system is vibrating on its own. So such a system or such a vibration is known as free vibration, and example is simple pendulum. And the second case is forced vibration. When the system is under the influence of external force, so such vibration caused because of that external force is called as forced vibration. The best example for the forced vibration is one is machine tools and another one is electric bells. The example is electric bells or machine tools. So these are the examples for free and forced vibration. So now let us understand what do we mean by linear and non-linear vibration. So first let us understand what is the meaning of linear and non-linear vibration. If in a vibratory system, the mass, spring and damper behave in a linear manner, then the vibrations caused are known as linear vibrations. Say for example, I have one system, so where I have one mass and I have one spring and I have one damper. If this system behaves linearly, then I will call it as a sorry, I have to place mass here. There is a system which consists of mass, spring and a damper. If this system behaves linearly, then it is called as linear vibration. And on the other hand, if any of the basic components of a vibratory system behaves non-linearly, then the vibration is called as non-linear vibration. Linear vibrations are governed by the linear differential equations, while the linear vibration become non-linear for very large amplitude of vibration. So these are the two types. So let us go for the third type of vibration. The third one is, let us discuss the third one, that is the damped and undamped vibration. Damped and undamped vibration. If the vibratory system has damper, then the motion of the system will be opposed by it. So once again I will repeat, if the vibratory system has a damper as one of its component, then the motion of the system will be opposed by it and the energy of the system will be dissipated in friction. This type of vibration is called as damped vibration. The system having no damper is called as undamped vibration. And the fourth one is deterministic. Fourth one is deterministic and random vibration. Deterministic and random vibration. That is the fourth case. If in the vibratory system the amount of external excitation is known in magnitude, it causes deterministic vibration, whereas contrary to it, non-deterministic vibrations are known as random vibrations. The fifth one is transient vibration. Fifth one is the transient vibration. In an ideal system, the free vibrations continue indefinitely as there is no damping. The amplitude of vibration decays continuously because of damping and vanishes ultimately. Such vibration in a real system is called as transient vibration. And the last one is longitudinal transverse and torsional vibration. And the last one is longitudinal transverse and torsional vibration. Longitudinal transverse and torsional vibrations. If the mass, suppose say I have one system where I have attached one mass. If the mass moves up and down parallel to the spindle axis, so let us consider this as our axis. If this mass moves up and down parallel to this axis, then it is said to execute longitudinal vibrations. When the particles of the body or the shaft move approximately perpendicular to the axis of the shaft, then the vibrations are called as transverse vibrations. Please understand what is longitudinal transverse. If this mass moves up and down parallel to this spindle axis, then it is called as a longitudinal vibration. Whereas if this mass moves perpendicular to this longitudinal axis of the shaft, then the vibrations caused are called as or known as transverse vibrations. And the last one is torsional vibration. If the spindle gets alternately twisted and untwisted on account of vibratory motion of the suspended disc, then it is said to undergo torsional vibration. Say for example, if this shaft alternately it is twisted and untwisted. If it is twisted and untwisted on account of vibratory motion of the suspended disc, then it is said to execute torsional vibration. So these are the different varieties of vibration. So initially we have discussed what do you mean by vibration, what are the causes of the vibration, how to reduce the vibration. Then we have discussed different types of vibration. In different types of vibration, first we have discussed free and forced vibration. Then we have discussed linear and non-linear vibration. Then we have discussed damped and undamped vibration. Then we have discussed deterministic and random vibration. Then we have discussed what do you mean by transient vibration. And then we have discussed longitudinal, transverse and torsional vibration. So we have discussed totally the 6 different varieties of vibration. So let us understand now the different definitions associated with this vibration. Now let us understand the different basic definitions which are associated with the vibration. So in that, the first one is periodic motion. The first one is periodic motion. Already these notes I have shared with you in your class WhatsApp group. So once again you can go through the same notes. So first one is periodic motion. So what is periodic motion? A motion which repeats itself after equal interval of time. Once again I will repeat, a motion which repeats itself after equal interval of time is called as periodic motion. Second one is time period. Second one is time period. The time taken to complete one cycle is known as time period. The time taken to complete one cycle is known as time period. Third one is frequency. Third one is frequency. So what is the definition of frequency? The number of cycles per unit time is called as frequency. So that is the third definition. Fourth one is amplitude. The fourth one is amplitude. So what is the definition of the amplitude? The maximum displacement of a vibrating body from its equilibrium position. The maximum displacement of a vibrating body from its equilibrium position is called as amplitude. The next one is fifth one. That is nothing but natural frequency. The fifth one is natural frequency. What is the definition of natural frequency? When no external force acts on the system after giving it an initial displacement, the body starts to vibrate. So these vibrations are called as free vibrations and their frequency as natural frequency, and it is denoted by radian per second, or it is represented in terms of hertz. So once again I will repeat. First, to understand natural frequency, it is necessary to understand what is free vibrations. When no external force acts on the system after giving it an initial displacement, the body starts to vibrate. Say for example, simple pendulum. So I have simple pendulum here. Initially I am going to give it an excitement. So after giving it excitement, so it comes to this position. So after giving an initial force or external force acts on the system, after giving it an initial displacement, the body starts to vibrate. So these vibrations are called as free vibrations, and their frequency is called as natural frequency, and it is represented by radian per second, or it is represented by hertz. So this is the definition of natural frequency. The next term is degree of freedom. So degree of freedom we have discussed many of the times while solving the problems. So what is the definition of degree of freedom? The minimum number of independent parameters which are required to describe the position of an entity completely in space is known as degree of freedom, or the minimum number of independent coordinates required to specify the motion of a system at any instant is known as degree of freedom. The next term is the last one for today's class, that is nothing but simple harmonic motion. So it is very important. The last one for today's class, that is the simple harmonic motion. The motion of a body to and fro about a fixed point is called as simple harmonic motion. So as I have told, in case of simple pendulum, so how it is going to move? So it is going to move to this point, to this point. So it means if I give an initial excitation to this simple pendulum, the body starts to move, and it is called as to and fro motion about this fixed point. So it starts to move from this point to this point until the total amount of external excitation, whatever it is given, till it becomes zero. So it starts to move about a fixed point, and it is called as to and fro motion about a fixed point, and that is called as simple harmonic motion. This motion is periodic, and its acceleration is always directed towards the mean position, and it is proportional to its distance from the mean position. So let's consider a body having a simple harmonic motion. Consider a body having a simple harmonic motion. Consider a body having a simple harmonic motion, and it is represented by equation x is equal to a into sine of omega t. X is equal to a into sine of omega t. So body having a simple harmonic motion is represented by x is equal to a into sine omega t, where x means it is a displacement. So now if I differentiate it, so it becomes x dot, and the differentiation of a sine omega t is a into omega into cos omega t. So if I differentiate the displacement, then it comes velocity. So if I differentiate velocity, then it becomes acceleration. So it is represented by x double dot. So it is nothing but minus of a into omega square into sine of omega t, into sine of omega t. But we know that a into sine omega t is nothing but it is x. So replace a sine omega t. So x double dot is equal to minus omega square into x, because a into sine omega t is nothing but it is x. So x double dot is equal to minus omega square into x, where x represents displacement, x dot represents velocity, and x double dot represents acceleration. So x means displacement, x dot means velocity, and x double dot means acceleration. So this equation always you have to remember. For a body having simple harmonic motion, its displacement is represented by the equation x is equal to a sine omega t. So if I differentiate this displacement, I will get velocity, and if I differentiate velocity, I am going to get acceleration. So the acceleration is given by x is equal to minus omega square into x, where x means displacement, x dot means velocity, and x double dot means it is acceleration. So next definition is resonance. So resonance definition is when the frequency of the external excitation is equal or it is same as the natural frequency of a vibrating body, the amplitude of vibration becomes excessively large, and this concept is known as the resonance. So this completes the problem, the basic definitions and the basic types of vibrations associated with the concept of vibration. In the next class, we are going to discuss what do you mean by simple harmonic motion and what are the different parts of a vibrating system. Then we are going to discuss the addition of harmonic motions and problems on addition of harmonic motions. So this completes today's class. Thank you.